Okay, so we want to look at the 2022 question now. And in looking at the 2022 question, we start off with the first question, which is this. The subatomic particles located in the nucleus of an atom are, is it neutron and protons? Is it proton and electron? Is it proton and ions? Is it neutron and electrons? So the answer to this one is actually A, neutron and proton. That's the subatomic particles that is located in the nucleus of an atom. So the nucleus of an atom contains two types of subatomic particles, which are the proton, which carries a positive charge, and then the neutrons, which are neutral. Electrons are located outside the nucleus in the electron cloud or orbital. So option A is the right answer. Second question say we should look at what is the IUPAC nomenclature of that particular structure above? Is it 3-chloro, 3-methyl-butane, 2,2-dichloro, 3-methyl-butane, 3-methyl-chlorobutane, or 2-chloro, 2-methyl-butane? So let's look at it. The right answer here is but before we look at it, let's the right answer is actually what's it called? Option D. Option D. I don't know why I did not put that in that question. Sorry about that. Is option D. But if you look at it critically and we want to try to analyze what is there, looking at the longest carbon chain, which is 4 carbon atom, that means that it's a butane. And then it has a methyl group that is attached to the second carbon. And it has a chloro group that is also attached to the second carbon. So based on that, we can say that both the chloro and methyl groups substituted are on the carbon, are on carbon 2. Therefore, using IUPAC rules, the name becomes 2-chloro, 2-methyl-butane. Okay. The next one says SO2 plus O2 to give us 2SO3. In the reaction above, the most suitable catalyst is it chromium 6 oxide, iron 3 oxide, copper 1 oxide, or vanadium 5 oxide? So the right answer to this one is actually option D, vanadium 5 oxide. And the conversion of SO2 to SO3 is the key step in the contact process for producing sulfuric acid. The most efficient and commonly used catalyst for this reaction is vanadium 5 oxide, and it provides a surface for the reaction to proceed efficiently at a suitable temperature. In the preparation of salts, the method employed will depend on A, is it the composition, or dissociating ability, or the stability to eat, or the precipitating ability? The right answer is the stability to eat. And the reason is because the method of salt preparation depends greatly on the thermal stability of the salt being prepared. Excuse me, please. So for example, salts that are decomposed by heat cannot be prepared by methods involving eating. Therefore, understanding a salt's stability to eat is crucial for selecting an appropriate preparation method. Okay. The following non-metal forms acidic oxide with oxygen, except is it phosphorus, sulfur, carbon, or chlorine, except chlorine. And the reason is because most non-metals form acidic oxide when combined with oxygen. Example includes phosphorus, P4O10, sulfur, SO2 or SO3, and then carbon, CO2. Okay. How many neutrons are present in an atom with mass number 37 and atomic number 17? How many neutrons are present in an atom with mass number 37 and atomic number 17? So let's look at the options. And if you look at it carefully and you work it out appropriately, you will end up having this as your answer, which is 20. And how did we arrive at that? To find the number of neutrons, neutron equals to mass number minus atomic number, which is 37 minus 17, and that will give us 20. The sulfide that is commonly used in coating electric fluorescent tube is it iron 2 sulfide, tin 2 sulfide, zinc sulfide, or lead 2 sulfide? So which one is it? And the answer is zinc sulfide. Zinc sulfide is widely used in fluorescent coating because of its phosphorescent properties. It glows when exposed to ultraviolet light, making it ideal for use in electric fluorescent tubes. An organic compound which liberates carbon dioxide from trials to be, is it ethanol C2H5OH or C3H4 or C6H6 or CH3COOH? So the answer here is CH3COOH. That's arachidonic acid, an arachidonic acid called ethanoic acid. Okay, so carboxylic acid, like ethanoic acid, reacts with carbonates to liberate CO2. Okay. Now, the question is, addition of sodium chloride to water to form a solution will lead to, is it A, increase in freezing point and increase the boiling point, increase in freezing point and decrease the boiling point, decrease in freezing point and decrease the boiling point, or decrease in freezing point and increase the boiling point? According to this, it will be a decrease in freezing point and increase the boiling point. So this is due to the colligative properties of solutions. Adding NaCl lowers freezing point, that's the freezing point depression, and raises boiling point, which is the boiling point elevation. A chemical widely used as a fertilizer is galena, bauxite, emerald, nitrochalk. The answer is nitrochalk, and the reason is because nitrochalk is a common fertilizer composed mainly of calcium ammonium nitrate, providing essential nitrogen to crops. And then galena on the other hand is just lead ore, bauxite is aluminum ore, and then emerald is gemstone, not used in fertilizer. Okay. Based on the electrochemical series, which of these ions will show the greater tendency to be discharged at the cathode in an electrolytic cell? Is it copper 2, iron 2, tin 2 rather, iron 2, and then zinc 2? It's copper 2, and the reason is because if the electrochemical series, the lower an ion is, the more easily it is discharged at the cathode. Copper 2 ion lies below tin 2, and iron 2 and zinc 2, meaning it is more readily reduced to its metal at the cathode during electrolysis. Okay. Addition of charcoal to the filter bed of sand during water treatment for township supply is to prevent goiter, prevent tooth decay, remove odor, kill germs. The correct answer is remove odor. Activated charcoal or carbon is used in water treatment due to its adsorptive properties, particularly for removing organic compounds and odors. It does not kill germs or prevent goiter. Its main purpose is to remove taste and smell impurities. Okay, all right. See. So that's for that. Question number 13 says that using the metal activity series, which metal can liberate hydrogen gas from steam? Our options are listed. What do you think? What do you think is the right answer to this one? Tell me in the comment section. I would like to know. Okay. All right. See? So looking at these options carefully, the right option for us here is iron. And the reason is that in the reactivity series, metal above hydrogen can liberate heat from acid or water steam. Now, so iron is high enough to react with steam to produce hydrogen gas. And you can see that based on that equation that is there. So copper is below hydrogen and cannot liberate hydrogen. Simple, straightforward. This other one says that an organic compound with a fishy smell is likely to have a general formula of RCONHR1, RCONH2, RNH2, or RCOR1. The answer to this is RNH2, that's the amine. And compounds with the formula RNH2 are primary amine, which have characteristic fishy odor. RCONH2 is their hamites, so that's not the answer. RCOR1 are ketones, RCONHR are secondary amides, so that's not it. So the suitable answer there is RNH2, which are primary amines. Okay. Looking at this equation, which condition would produce the highest equilibrium yield for N2O4? Is it low temperature and high pressure? Low temperature and low pressure? High temperature and low pressure? High temperature and high pressure? So if you look at it critically, the right answer here is low temperature and high pressure. Why? The reaction is exothermic. So we've established that. And because the reaction is exothermic, so low temperature favors the formation of N2O4. There are fewer moles on the left, 1 mole, than on the right, 2 moles. So high pressure will also favor the side with the fewer gas molecules, and that is N2O4. Thus, low temperature and high pressure favor formation of N2O4. Okay. Zinc plus 2HCl will give us zinc chloride plus H2O. What happens to zinc in the above reaction? Was it oxidized? Is it a reactant? Was it reduced? Or is it just a metal? The answer is it was oxidized. And why? In this redox reaction, zinc loses electron to form zinc 2 plus in zinc chloride, which is the definition of oxidation. So zinc is oxidized in this regard, moving from oxidation of 0 to +2. An increment in oxidation number is an oxidation. Okay, so it was oxidized in that reaction. So this one says that an organic functional group which can likely decolorize ammoniacal silver nitrate is it alkene, alkyne, or alkano? The answer is alkyne, and a terminal alkyne reacts with Toline's reagents, ammoniacal silver nitrate, to form a white precipitate of silver acetylide, which decolorizes the reagent. Alkenes decolorizes bromine water, not ammoniacal silver nitrate. A colored gas that is known to be poisonous and can readily damage the mucous lining of the lungs is A, hydrogen sulfide, B, carbon 2 oxide, C, chlorine, D, sulfur 4 oxide. And the right answer for this one is D, sulfur 4 oxide. Sulfur 4 oxide is a pungent smelling toxic gas that can irritate and damage the respiratory tract and mucous membrane. It is also a contributor to acid rain. Okay. All right. So we move on to the next question now. Question 19. In order to electroplate a spoon with silver, the arrangement of the electrolytic cell is the anode is a silver rod and the cathode is the spoon. The anode is the spoon and the cathode is a silver rod. The electrolyte is silver triazonitrate 5 solution, and the cathode is silver rod. The electrolyte is silver triazonitrate 5 solution, and the anode is the spoon. So the right option here is A. The anode is silver rod, and the cathode is the spoon. So in electroplating, the item to be plated, the spoon, is the cathode. Why the metal, which is silver, is the anode. Silver from the anode dissolves and plates the spoon. That's the cathode. The electrolyte is typically silver nitrate. So that's the setup for that. 20 says that an organic compound that decolorizes bromine water is likely to be C3H8, C2H6, C4H10, or C2H4. So most definitely it should be an alkene, with double bond, C double bond, And when we look at those options there, you look at it carefully, you know that the right option for us is C2H4, C2H4. Okay, C2H4. 18 is an alkene, which contains a double bond. Alkenes react with bromine water, decolonizing it due to its addition reaction. Alkanes C3H8 C2H6 and C4H10 do not react with bromine water under normal conditions. Okay. Crude petroleum is converted to useful products by the process of A, fractional distillation, B, A, fractional crystallization, B, fractional distillation, C, filtration, D, chromatography. The answer is fractional distillation. And crude petroleum is a mixture of hydrocarbon that is separated into useful components like petrol, kerosene, and diesel using fractional distillation, which separates substances based on differences in their boiling points. Okay. So an organic compound contains 69% carbon, 15.3% hydrogen, and 30.7% oxygen. Calculate the empirical formula. Calculate the empirical formula. Is it option A, option B, option C, or option D? The answer is option C. Excuse me, please. C4H9O. And how did we arrive at that? First, convert the percentage to moles. So 69 divided by 12 will give us 5.75. 15.3 divided by 1, which is the relative atomic mass, that will be 15.3. 30.7 divided by 16, which is the relative atomic mass of oxygen, that will give us 1.92. So you divide by the smallest, which is 1.92. And when you do that, you have a relationship of carbon having three hydrogen 8, and then oxygen 1. So that is what we'll have there. So the right answer for all should be, I don't know. Okay. I think there's a little mix-up, please. Pardon me, please. I did not take note of this. I'm so sorry. So the option should be C3H9O actually, based on our calculation. It should be C3 carbon, H8, and then oxygen 1. C3H8 O. That's oxygen. So that's the option. That's D, please. Pardon me. D, not C. Thank you. Hydrogen plus oxygen gives us 2H2O. From the equation above, calculate the volume of unreacted oxygen gas if a mixture of 50 cm3 of hydrogen and 75 cm3 of oxygen are involved. So we have these options lined up for us to choose from. So the right answer after the calculation should give us D, which is 50 cm3. From the equation, 2 volumes of hydrogen react with 1 volume of oxygen. So 50 cm3 of hydrogen will require 25 cm3 of what? Of oxygen. So that's that. So based on these, we'll need 50 cm3 of that hydrogen to be able to react that. Okay. In which of the following will hydrogen form ionic compound? Is it in HCl, NaH, Na3, or CH4? The answer here should be A or B. Is it B? Okay, sodium hydride. Yeah, sodium hydride. Yeah. B, sodium hydride. In sodium hydride, hydrogen exists as -1 hydride and forms an ionic bond with sodium. In other options, hydrogen forms covalent bonds. Okay. If the volume of a given mass of a gas at 0 degrees Celsius is 29.5 cm3, what would be the volume of the gas at 15 degrees Celsius, assuming constant pressure? Assuming constant pressure. Is it A, 31.6, B, 62.2, C, 32.7, or D, 31.1? So when we go through the calculation, the right answer should be about 31.1. And how did we arrive at that? Using Charles' law, V1 over T1 equals to V2 over T2. We have our V1 to be 29.5 cm3, our T1 to be 273 Kelvin, and then our T2 to be 288 Kelvin. How did we arrive at that? 0 plus 273 will give us 273 Kelvin. 15 plus 273 give us 288 Kelvin. So we are converting from degrees Celsius to Kelvin. So based on that, our V2, making it the study of the formula, will now arrive at 31.1 cm3. Right. See? The reaction below represent neutralization reactions, in which In which of them is the value of delta H highest? Is it in option A, option B, option C, or option D? So the answer is option C. And the reaction between a strong acid and a strong base is a complete neutralization and gives the highest enthalpy energy. It is an exothermic process with the maximum energy release due to full ionization of both acid and base. Okay. The pollutants usually present in a city which generates its electricity from coal is A, fog, B, carbon-2 oxide, C, smog, D, sulfur-4 oxide. So the answer here is sulfur-4 oxide. So coal contains sulfur compounds. When coal is burned for electricity, sulfur-4 oxide is released, which contributes to acid rain and respiratory problems. Okay. The dehydration of CH3, CH2, CH2, CH2OH will give us what? Is it option A, option B, option C, or option D? And the right answer to this is option D, CH3CH, double bond CH, CH3. Dehydration of butan-1-hol. In the presence of an acid catalyst, e.g. H2SO4 removes water, producing but2-ene, which is CH3CH, double bond CH, CH3, through an elimination process. Okay. When it is absorbed during a chemical reaction, the reaction is said to be thermodynamic, B, exothermic, C, isothermal, D, endothermic. So when it is absorbed, we say that that reaction is what? Endothermic, D. An endothermic reaction absorbs heat from its surrounding, the system gains energy, and the temperature of the surrounding may drop. Then question 30 says that which of the following best represents a solid gas mixture? A solid gas mixture. Is it a milk? Is it B, kerosene? Is it C, soil? Or D, smoke? The right answer is smoke. Smoke is a mixture of solid particles, e.g. soot, ash, dispersed in a gas, usually air. Hence, it is classified as a solid gas mixture. The equation above illustrates what now? What does it illustrate? So let's look at it. Is it precipitation? Is it hydration? Is it hydrolysis or neutralization? Okay, the right answer to this one is neutralization. This is a classic neutralization between an acid H plus and a base OH forming water. It is a fundamental acid-base reaction. Electrons enter into orbitals in order of increasing energy as exemplified by 1s2, 2s2, 2px2, 2py2, 2pz0, and 3s0. And it goes on like that with our option B, our option C, and our option D. So carefully look at it. Which one do you think is the right answer there? And if you carefully consider it, you discover that option B is the right answer. So electrons will enter into orbitals in order of increasing energy as simplified by 1s2, 2s2, 2px2, and 2py1, and 2pz1, and then 3s0. So electron field orbitals following the off-bow principle and Hund's rule, which ensure that electrons occupy degenerate orbitals like 2p singly first in option B, and electrons are distributed singly among the 2p orbitals before pairing starts, which is correct. Okay. Wrought iron is obtained by heating cast iron in a furnace with magnetite, hematite, carbon-2 oxide, and calcium triosilicate 4. So the right answer to this one is hematite, and that is like an ore of iron. Wrought iron is purified cast iron. This purification is done by oxidation in the presence of hematite, that's Fe2O3, in a furnace which removes carbon and other impurities. Okay. So in the extraction of iron, hot air is introduced into the blast furnace through valves, open heads, arcs, or tuyères? And the answer to these is tuyères. And what is it? It is basically in the blast furnace, hot air is blasted through tuyères, and those are just these are just nozzles actually at the bottom to initiate combustion and reduction reaction necessary for extracting iron from its ore. Okay. How many bonding pairs are present in carbon 4 oxide? Is it 4? Is it 3? Is it 2 or 1? Okay. The answer here is 4. We have 4 that is present. And carbon 4 oxide CO2 has the structure O double bond C double bond O. Each double bond between carbon and oxygen consists of 2 bonding pairs, making 4 bonding pairs in total. Okay. 2-methyl-prop-1-ene is a structural isomer of A, but-1-ine, 2-methyl-but-1-ene, 3-methyl-prop-1-ine, D, but-2-ene. So the structural isomer of but-2-ene, and if you look at it, they are structural isomers because they have the same molecular formula, but different structural arrangements. One is branch, 2-methylpropene, and the other is a straight chain, but-2-ene. Alkanes are used mainly in the textile industry, in the hydrogenation of oils, as domestic, what's it called, industrial fuels, and as fine chemicals. So alkanes are mainly used as what now? They are mainly used as domestic and industrial fuels. Alkanes like methane, propane, butane are highly combustible and primarily used as fuel for domestic and industrial purposes due to their high energy content and availability. So that's that. That's that for that. So please let's take note of that. Very important. What volume of water in dm cube must be added to 10 dm cube of 2.0 mole per dm cube HCl to obtain a 0.5 mole per dm cube solution? Is it 30? Is it 40? Is it 20 or 50? Now, the answer is 30. How did we arrive at this? Explanation is basically when you use the dilution formula, which is C1V1 equals to C2V2, where our C1 in this case is 2.0 mole per dm cube, our V1 is 10 dm cube, our C2 is 0.5 mole per dm cube, and our V2 is unknown. So when you have a 20 multiplied by 10, which will be equals to 0.5 multiplied by the volume that is unknown. So our volume of water to be added will be basically 20 divided by 0.5, and that is 40 dm cube, 40 dm cube. So if you now look at it, the volume of water that will be added will now be what? V2 minus V1. That's 30 minus 40 minus 10, and that will give us 30 dm cube. Okay. Now the above table shows the composition of the atmosphere of planet X. Which of these gases are present in higher percentage on Earth? Is it option A, CO2 and O2, option B, N2 and CO2, option C, CO2, O2 and N2, or option D, O2 and N2? The answer to these is D, oxygen and nitrogen. And basically on the Earth, nitrogen is 78% and oxygen is 21%. They are the most abundant, or they are more abundant than on planet X. So compared to what's it called? Pardon me, please. Let's recap again. On Earth, nitrogen has a percentage of 78% in the air. Oxygen is 21% in the air on Earth, and so they are the most abundant on planet X. And for this one, you have your N2 to be 72, and your oxygen to be 24. CO2 on Earth is only about 0.04%, much lower than 4%. So so that's that for that. So oxygen and nitrogen it is then. Hard water is water with high concentration of dissolved ions, in particular calcium, and is it magnesium ions or nitrogen ions, phosphorus ion, or helium ion? So the answer to this is magnesium ion, magnesium ion. Hard water contains high level of calcium and magnesium ion, which prevents soap from lathering easily and causes scaling in pipes. All righty. Thank you very much for joining me in this past question that we just treated. So we'll take on the next year very shortly. So please stay tuned and key in, and thank you once again. Bye for now.